Welcome to this lesson. In this lesson, we are going to look at mechanics, and we'll be looking at equilibrium of forces. So when you say equilibrium of forces, you mean that when forces F1, F2, F3 up to forces Fn, when they are acting upon a particle in equilibrium, if you add all the forces F1 plus F2 plus F3 plus Fn, should give us 0. So when you express the forces in this way, then we say we are expressing forces in equilibrium. So let's take example 1. So example 1 states that two forces F1 given by 4 Newton 060 degrees and F2 which is 2 Newton 225 degrees are acted on the body. Find the magnitude and direction of the third force F3. Good. So we need to resolve these forces. So F1, when we resolve it into vectors, will be 4 sine 60, 4 cos 60, which will give us, so 4 sine 60 will give us 3.464. Then 4 cos 60 will give us 2. Then we resolve F2, which is equal to 2 sine 225, 2 cos 225. So 2 sine 225 will give us minus 1.414. Then 2 cos 225 will give us the same thing, minus 1.414. So we have resolved the vectors. So in equilibrium, force 1 plus force 2 plus force 3 will give us 0. So let's set them in. Force 1 is 3.4616. Then for 2, good. This force 1. Force 2 is negative 1.414. Negative 1.414 plus F3 should give us 0, 0, 0 in terms of vectors. So we add these two forces. So it will be 3.14416. So this plus negative 1.414. Then here will be plus negative 1.414 plus f3 should give us 0, 0 vector. So let's add it. So 416 minus 1.414. So get 2.002. Then we have 2 minus 1.414. It also gives us 0.586 plus f3 is equal to 0, 0. So to find f3, we now move this one to the side. So it will be minus 2.002 minus 0.586. So this will be the f3. Then we now find the magnitude and direction. Let's start now. So we find f3 in magnitude to be root of 2.02 square minus 2.02 square plus minus 0.586 square. So when you use calculator and point this, we are going to get 2.2 Newton. So let's find the direction. We are finding the direction. So you just rule your coordinate x, y. And f1 was minus 2.02 minus 0.586. So all negative, it means the angle will be formed here. So all will be negative here. So you form the angle here, then put theta here. So the x, you put the x 0.02 here. Then the y is 0.586. So here will be the opposite. So tan theta is 0.586 over 2.02. So theta will be equal to tan inverse of 0.586 over 2.02. So this one will give us 16 degrees. But we can see that this one is within 270. Here is 90 degrees. Here is 180 degrees. Here is 270. It's within 270. So direction is equal to 270 minus 16, which will give us 254 degrees. So therefore our F3 will be 2.2 Newton to 254 degrees. This will be our F3. So let's still solve more examples here. So let's check the second example. So the example is saying that two forces F1 equal to 3I minus 4G and F2 equals to minus 14i minus 3g. Good. You should find the third force that will keep the body in equilibrium. Okay, so we have solution. So F1 will be equal to 3 minus 4. F2 will be equal to minus 14 minus 3. Good. So for the first at equilibrium, F1 plus F2 plus F3 should give us 0. Therefore, our F1 is 3 minus 4 plus negative 14 minus 3 plus F3 should give us 0, 0. So let's add these two. We get minus 11 minus 7 plus F3 is equal to 0, 0. Good. So when you do this, you are going to get F3 is equal to 11, 7. Therefore, our F3 shall be 11i plus 7g. 11i plus 7g. Good. So the same equilibrium, let's use Lamy's theorem. So we are going to Lamy's theorem. Lamy's theorem of equilibrium of forces. So let's say we have 3 forces, F1, F2, F3, and they are acting on a body in equilibrium such that the angles between them are theta, alpha, and beta. We can illustrate this as that in this diagram. So here we get F1, then F2, F3. So then you put the angle there, theta, beta, then alpha. So when we have 3 particles acting on the body, forces acting on the body in equilibrium, the angles and angles between them, Lamy's theorem states that F1 over sine 180 minus, see the one facing the F1 beta should be equal to F2 over sine 180 minus the one facing F2. F2 is alpha is equal to F3 over sine 180 minus the one facing F3, which is theta. So this one, when you talk of F1, it's facing beta here. In talk of F2, it's facing alpha here. F3 facing theta here. So that is Lamy's theorem. That is Lamy's theorem. So we are going to take example of Lamy's theorem. So we have a question that one end of a string is like a rope, 0.8 meters long, is fixed to a point O. So fixed to point O, and the other end is fastened to a small object of weight 12 Newton. The object is pulled aside by a horizontal force until it is 5 meters from the vertical. So let's illustrate this. So we have the point O, then the particle with weight. So if with weight 12 Newton is that here, and this particle is pulled. So when you pull it, the particle will form like this till it is 5 meters. It is 0.5 meters, 0.5 meters away, and the string itself is 0.8 meters. So if the string is here, then you pull it, it will fall something like this. So this force will no longer be here because it's this force that pulled it 0.5 meters. So the force will now come here, the weight will now come here. W is equal to 12 Newton. Then the force pulling it will be the F. So we are to find the force, we are to find the magnitude of the tension, because there will be tension within the force, within the particle. So let's do that. We draw the diagram. Let us redraw the diagram this way. So it will be point O, because this will be imaginary one, because this one has been pulled here, and this is the string is 0.8 meters. It's pulled to the horizontal until it is 0.5 meters. So there will be a force here pulling it. There will be a force here, and the weight will now be here. So the weight is 12 Newton. Good. So we can indicate an angle here, theta. So we have adjacent hypotenuse. So we have cos theta is equal to adjacent 0.5 over hypotenuse 0.8. So theta will be cos inverse of 0.5 over 0.8, and which will give us 51.32 degrees with a calculator. So here will be 51.32. So let's restructure the diagram with the Lamy's theorem. So we have that the force will be here, the horizontal force will be there, then the weight will also be here, 12 Newton. So the tension is here. Good. So since the tension, the O point O will be here. So if you look at this, there's an imaginary line here. Good. Means here is 90. From here to here is 90 degrees. And this side is what we have obtained, 51.32 degrees. So if we add it to 90, what are you going to get? So we are going to get we are going to get 141.32 degrees. We're going to get one, and we know that this side is 90 degrees. So how are you going to find this? It's just 141 plus 90 minus 360. So 360 minus 90 minus 141.32. We will get 128.68 degrees. So with this, we can set out our Lamy's theorem. So which will be T over sine 180 minus 90 is equal to W over sine 180 minus 128.68 is equal to F over sine 180 minus F 141.32. Good. So let's go on and solve them. So now let's go on. T has not been given over sine 90, because 90, 180 minus 90 is 90, is equal to W is 12 over sine 51.32, because 51.32 is equal to F over sine 38.68. 38, because when you subtract this one, that's what you're going to get. So you can use cross multiplication. So therefore, sine 51.32 times T is equal to 12 times sine 90. So let's divide both sides by the number behind the T. Good. So T will be equal to 12 sine 90 over sine 51.32. So our tension will be 15.37 Newton. So let's look at our force. Let's check our force now. So we are finding for the force the same way. 12 over sine 51.32 is equal to F over sine 38.68. So do cross multiplication. 12 times sine 38.68 over sine 51.32 will give us the F. Therefore, our F is equal to 9.61 Newton. So we are done with them. So our tension is 15.37, but our force is 9.61 Newton. Let us take the second example. The second example 2. They state that a body of weight 15 Newton is suspended by means of two inextensible strings, good, which are inclined at 60 degrees and 30 degrees to the downward vertical. We have to calculate the tensions in the string. Good. So let's take the solution. So it's a body of weight 12 Newton is suspended by means of two inextensible string. So let's say we have the point where the 2 points will be fixed. First string has been fixed here, and this string has been fixed here. Then we tie it to the weight. We tie this to the weight here. So we put the weight, it's got to 15 Newton. That's the weight. And say that they are suspended by means of two inextensible string. So you can call here tension 1, you can call here tension 2. These are the strings. Inclined at 60 degrees and 30 degrees to the downward vertical. So here is 60 degrees and this side is 30 degrees. So if you have imaginary line here, here will be 90, so therefore here will be what? 30 degrees. Here too will be 90 degrees, so this side will be 60 degrees. So it's up to us to sketch the Lamy's diagram for the Lamy's theorem. This is the illustration. So the two strings will fix to this point and that point, and they will suspend the weight at this vertical. So the weight will be 15 Newton, and say that they are inclined at angle of 60 degrees and 30 degrees to the downward vertical. So downward vertical means to be here, 60 will be there, 30 will be here. Then when you complete it, since here is 90, here is 30, there will be 60 here. And here too, since when you complete it, since here will be 90, here will be 30 here. Good. So we are now going to draw a new diagram for the Lamy's theorem. But note that in the question, when they give you mass, to find weight is equal to mass times gravity, because weight is a force. So therefore, when they give you mass of 2 kilograms or so, the weight will be 2 times 10, which is 20 Newton. So we have to take note. So let's draw it and solve the question. Good. So we can redraw the whole diagram this way. We have the weights which has been suspended. W is equal to 15 Newton. Then we have tension 1, tension 1, then we have tension 2. So what we will notice is that we were having the first diagram, we were having this side, this line was there. Good. So, and we got here to be 30, we got here to be 60. So if you add this 30 to the 90, you get all of this to be 120 degrees. adhere to, when you add the whole of this, you get 150 degrees. So the remaining one will be 90 degrees. So you can now solve our tension. So we will start W over sine 180 minus 90, because W is facing 90, is equal to T1 over sine 180 minus T1 is facing 150, is equal to T2 over sine 180 minus T2 is facing 120 degrees. So when you set it, W is 15 over sine 90 over sine 90 is equal to T1 over sine 30 is equal to T2 over sine 60. So let's solve for T1. So solve for T1 is 15 over sine 90 should be equal to T1 over sine 30. So use this one to multiply this, the results will come. So our T1 is equal to 15 times sine 30 over sine 90, and we are going to get, so our T1 will be equal to 7.50 Newton. Good. So let's look for T2. So our T2, we are going to still equate this one to this one. So we have 15 over sine 90 is equal to T2 over sine 60. So this one to go and multiply this, get T2. So 15 times sine 60 over sine 90 will give us T2. So T2 is equal to, you get 12.99 Newton. So we have found the two tensions. So good, we'll continue with the rest of them. So learn them and you'll be able to do more. Good.